Good morning. So today we're going to be looking at a continuation of what we did yesterday in math using repeated addition or subtraction to do division questions. So first I want to take a look at the homework, the work that I gave you or the examples. So 42 divided by 5, we're going to just be skip counting, remember? We're going to be skip counting. I'm just going to go over here. Actually, I'll just start a new one. So we start with 5, right? And then we go 10, 15, 20, 25, 30, 35, 40, and then I can't go any higher. So I'm going to count how many I got here. 1, 2, 3, 4, 5, 6, 7, 8. So then my answer is 8. So 8 goes into 42. 5 goes into 42 8 times. And we're going to do the sixth one over here with 29. Start with 6, 12, 18, 24, 30. Oops, went too far. So this 30 gets knocked off. And we know that 6 into 29 goes 1, 2, 3, 4 times. So the answer there is 4. So today we're going to take this idea of skip counting to find out division questions. We're going to take it a little further and do slightly more challenging numbers. So let me show you how that works. So we're going to do this problem. So let's say a group of 6 friends are playing cards and they want to play War, which is a game in which all cards are handed out to the player. So every single one of the cards are handed out. If you ever play War, it's just the highest card wins. They're playing with several decks, so they've put more than one deck of cards together because they can't find a full deck, so they just stick a bunch of cards together, which we usually do. So there are, in fact, 96 cards in total. All the cards have to be handed out. The question is, how many cards will each player get? So what we're really doing is taking the 96 and dividing it between 6 people. So how we do that problem? So this is the real math in this particular equation. We want to divide 96 by 6. So how many 6s go into the number 96? So we're going to use this repeated addition concept to try and figure this out. So we could do like a 6, 12, 18, but that would take us a long time. So instead, I want you to think of this. If I multiply 6 by 10, I can get to 60 right away. So I don't have to skip count 6, 12, 18, 24, 30, all the way to 60. I already know 10 times 6 is 60. So what I'm going to do is I'm going to put my 10 to the side here, and I'm going to subtract my 60 from 96 to see how much I have left. So there's my 10 that I got my 60 from. So I've skip counted 10 times or multiplied 6 times 10 to give me 60. So I know I have 10 sixes to get 60. I'm going to subtract to see what I've got left. Well, if I subtract 96 from 60 from 96, I get 36. So now the question is, I know that this has gotten me to 60. Now how many 6s are in 36? Right, so that's the next question. Well, I know how many 6s are in 36 because I remember my math facts, and I know that 6 times 6 is 36. So now all I have to do is go, well, I got 6 more 6s to account for here. I can put my other 6 here. I put my 10 from the 60, and I put my 6 here from 6 times 6, which is 36. I bring my 36 over here, and I'm going to subtract this one, whoops, from here to show that I have nothing left. And 36 from 36 is 0. So I've gotten all the numbers. I add this up, 10 plus 6 is 16. And that's how many 6s I've accounted for and subtracted from 96. Therefore, I know 96 divided by 6 is in fact 16. So that's a neat way to do a sort of a repeated addition version of this. It's not like skip counting because skip counting, I mean, it is in a way, but skip counting is a little more involved and it's trickier to try and count by 6s all the way to 96. But if you do it this way, then you basically have broken up that 96 into 60 whoops, 60 and 36, which are two manageable numbers that you know 6 goes into. So we're going to try a trickier one now. All right, so I want you to think about this question. So this is a little trickier. How would I do this? So I know that I can't skip count by fours all the way to 143. That's going to take a long time. So, but I do know what do I. So I have to ask myself, what do I know I can multiply 4 by that I can do in my head? I want to make it easy, so I'm going to do it in my head. I want something that I can do using mental math that is smaller than 143, but still pretty big. So I'm thinking 4 times 10 equals 40. So I know that 4 times 10 equals 40. So that's my first one. And now I'm going to take my 143, 143, and I'm going to take my 40, and I'm going to move it down here. Whoops, that's not what I want to do. Maybe I'll just copy it. I don't know what to do. So I'm going to take my 40. Let's try this again. There it is. I'm going to move it over here, and I'm going to subtract this to see how much I have left. So 140, and we can do that math question pretty easily. Just going to try and underline this here. So the math question there, that's pretty easy. So 0 from 3 is 3. And then 4 from 4 is 0. And then I'm just going to bring my 1 down. So there's that answer there. So now, because I've done the 10, 4 times 10 is 40, I'm going to remember this 10. I'm going to put it over here in the column so that I remember that I've used 10, and I'm just, for my own purposes, going to make it red so that you guys can see that that's part of my answer. This is where I'm going to keep track of the things that I've taken away from 143. So I've done 4 times 10. I'm going to record my 10 over here. It's giving me 40. I'm going to subtract it from 143. Now I've got 103 left. Well, I'm going to repeat this one because I know that it's 10 times 4 is 40, and it's still smaller than 103. So I'm just going to grab this, copy it, and paste it to make it easy for me. The marvels of a smart board. And whoops. And now I can subtract this again. So 0 from 3 is 3. And now 4 from 0 I cannot do. I have to borrow the 1. So 4 from 10 is 6. So now I've got 63 here. So it's getting better. I've got another 10 over here from this second multiplication. Now I've got 63. Well, guess what? I can do another one. Right? I can do another one. So here's this for this 40. That's for that 40. Now this is for another 40. Right? Because I can multiply it again. So now I can just subtract 0 from 3 is 3. And now it's getting really nice and small. I've got 23, right? Because 4 from 6 is 23. I'm going to put another 10 down here. Oops, and line that up nicely. There we go. That looks better. Now I can go, well, okay, so 4 times 10 is too big because that's 40, and 40 is bigger than 23. But what can I multiply 4 by that the answer is going to be less than 23, but something I can still do in my head? Well, I know my math facts, so I know that 4 times 5 is equal to 20. So 4 times 5 equals 20. So now I'm going to subtract my 20 over here. There's my 20. I'm going to subtract it. Uh, So now I can subtract it, and I get a lovely answer of 3. 4 doesn't go into 3, so I know that is my remainder. That's my leftovers. So, but 4 times 5 is 20, which means I'm going to take this 5. Oops. Move it over here with my 10s. And now all I have to do is add these up, and that's going to be my answer, right? So Add these guys up. Plus 0 plus 0 plus 5 is 5. 1, 2, 3. So now I know that 143 divided by 4 is in fact 35 with 3 left over. So I'm just going to bring this down here. And that's sort of how you use repeated addition using multiplying. So you're basically saying to yourself, what do I know? What can I multiply 4 by? 10's an easy one because I know 4 times 10 is 40. That's less than 143. And then I could sort of keep track in the column here of what I've multiplied it by. It's basically like skip counting, except I'm sort of cheating a little bit. I'm jumping ahead. So instead of just going 4, 12, 16, 20, 24, 28, 32, and then you're sort of getting confused because it's hard to skip count that high. I'm just going to go, well, instead of doing that, I know 4 times 10 is 40. There's my 40. So I've skip counted fours all the way to 40. That's sort of what I've done. I've just done it in my head. I know that 4 times 10 is 40. So I'm going to keep track of how many fours I have. I've got 10 fours. It's got that, subtract that, gives me 103. I'm going to do another 40. 4 times 10 is another 40. I'm going to subtract that. I get 63. I keep track of my other 40 here with the 10 fours. And then I've got 63. So 4 times 10 is another 40. There's my other 10 fours is over there. That gives me 23. 4 into 23, I know there's 4 times 5 is 20. So there's my 5, and I've got 3 left over. All I have to do is add up all the fours I've used. Well, I've used 35 fours, right? So 143 divided by 4 is 35, and we're going to say with remainder 3. So R3 stands for remainder 3. In other words, there's 3 left over at the end here. It doesn't go in evenly. There's a remainder of 3. So that just gives you an idea of how to go about doing division using this sort of strategy, which is really repeated addition, but it's also using some mental math strategies to make your job a little bit easier. All right. Thanks very much.